Direct substitution is going to be your easiest way to evaluate limits. However, you can't always use direct substitution. Okay? Direct substitution is for continuous functions. So not all functions are continuous. In fact, because we're in a chapter on limits, most likely they will not be continuous because they want you to know how to do all these different rules. So these are the simple ones. If I have the limit of x to the third minus 3x squared plus 9x, as x goes to 3, I simply plug in a 3, and there's my limit. If I have the limit as limit of 2 to the x minus 3 as x goes to 1, I plug in a 1, and there's my limit. Okay? Just plug it in and get an answer. Why can I do that? Because it's continuous. We'll talk about continuity later, but basically, from the left, from the right, and the function are all equal. The limit from the left, the limit from the right, and the function itself all equal the same. So I can just use direct substitution. You should always try direct substitution, even though probably 85–90% of the time it's not going to work, and you're going to have to do a different method. So on the second page, we're going to talk about the different methods you can use if direct substitution doesn't work. So try direct substitution, might not work, then we got to do another thing.
How did you get 27? Is it because
3 to the third.
Equals 27?
Nope, this is 27, then minus 20. This is also 27,
plus
and then plus 27.
Thank you. I was like, what?
These I'm just plugging in, folks. Just plugging in. Plug in a 5 here. Get this. Plug in a 2 here. Get this. Okay.
Thank you.
Now, if you missed something and you wanted to watch this video later, just scroll to what you missed. It could work. But the bottom line of this, all of this is just that sometimes you can use direct substitution. You should always try it. And if it doesn't work, we try something else. So that's our second page. So here we go. This is what happens. I come back to it at the end. Okay. Direct substitution does not always work. Sometimes you get 0 over 0 or 1 over 0 or something else. Okay? And now, if you end up with 0 in the denominator, we'll talk about a special case here, what you have to do. So here are some other methods. And you guys, I believe you did some of this last year. Some of it's going to look familiar. But one of the methods is you factor the numerator and the denominator and see if something will cancel. Okay? Now, if I try direct substitution here of 1, of the number 1, that's a 1, hopefully. That's what it says, right? X going 1. Okay.
Yeah.
So we basically, you can either think about it or actually write it down. I'll do a little thought bubble here. So I'm just thinking that if I do 3 times 1 squared, this is my thought bubble. 3 times 1 squared minus 1 minus 2 divided by 2 times 1 squared plus 1 minus 3. Let's see what happens. 3 minus 1, 0. 2 plus 1 minus 3, 0. 0 over 0. Okay, so I tried direct substitution. It didn't work. Now, the answer to this limit is not 0. Let me assure you. And even if it was, you wouldn't know at this point if it was 0. So you have to do something else. Okay? I'm not saying the answer is, well, I am saying the answer is not 0, but sometimes the answer could end up being 0 for this. But I want to assure you that you need to do something else to find that out. Okay? So what we do is, because this direct substitution didn't work, I get 0 over 0. This is a little hint toward those of you who are thinking deeply about this already. If I plug in a 1, and my numerator and denominator both equal 0, that means they share a common factor. If I plug in a 1, and both the numerator and denominator equal 0, it means they share a common factor. And that factor is x minus 1. Exactly. They must both have an x minus 1 in them in order to both equal 0 when you plug in a 1. Okay? So, in case you're wondering what these factors are, you already got one of the factors, x minus 1. Okay? So if you have trouble with this leading coefficient is not equal to 1 stuff, now I want you to carry along the limit notation. Okay? It doesn't take that long to write. In fact, I just wrote that in 3 seconds. So don't tell me it takes too long to write the limit notation. But as you go through this process of simplifying limits, I want you to carry that limit notation along because you are doing a limit. And I'll tell you when you can stop. So, what would this factor be? Well, I already said one of the factors can be x minus 1. So what is the other factor here? Obviously 3x, right?
Yeah. 3x plus 2.
A positive 2?
Yeah.
Because when I multiply negative 1 and a 2, I need to get negative 2. Let's double check, just to be sure. Because you're just taking my word for it. Let's see. X times 3x, 3x squared. X times 2, 2x. Negative 1 times 3 is negative 3. So we got positive 2, negative 3 makes negative 1, negative 1 times 2 is negative 2. So we factored this correctly, right? But that's your tip. Hopefully that's one of your main takeaways for today, is that if they both equal 0, they're going to share a common factor. Okay, we'll talk about, there's some other things down here that will make it more complicated, but let's just stick with that for now. 2x, again, because I have to, x times 2x is 2x squared. Now how am I going to make it negative 3?
Plus 3.
Plus 3. Okay, so what happens, this is where the magic happens, folks. This can now divide out. This can now divide out. And so now our limit simplifies. This is not a step that you necessarily have to write, but let me write it up here just so we can all be on the same page for a moment. X is going to 1, and now our limit is simply 3x plus 2 equals 2x plus 3. Okay, so our limit is simplified to this. And now we can use direct substitution because now it won't be 0 over 0. How nice is that? So at this point, you no longer need your limit notation. You just simply plug in 3 times 1 plus 2 over 2 times 1 plus 3, and we get 5 over 5, which equals 1. So this limit, the answer is 1. Because we can factor, we can get factors to cancel, and then we can use direct substitution. What questions do you have on that one? Probably one of the more popular ways to solve a limit. Yeah, go ahead, Raven. Okay, here's why. Because when I plug in a 1, I get 0, right? That means that one of the factors had to be x minus 1. Because if I plug in a 1, I get 0. Okay? And if I plugged in a 2 and got 0, then one of my factors would have been x minus 2. Okay? And so this is also something you guys learned back in, at least now it's true, I'm sure you use it in pre-calc too, it's been a while. The substitution, you can use synthetic substitution to evaluate polynomials. And remember, if you did the synthetic division and it came out to be 0, there was a factor. Remember that? The same thing here. If I plug in a 0 and I get 0, that means the factor was x minus 1. All right, let's talk about this one. I need some space. All right, let's try direct substitution because you never know, right? Negative 2 to the third, negative 2 to the third plus 8, and then we got negative 2 plus 2. So negative 2 to the third is negative 8, and that's plus 8 is 0, and then negative 2 plus 2 is 0, 0, 0. Okay, we got to do some more work, right? Direct substitution did not work. We need to do something else. But you want to check because in the test, you never know. In the quiz, I might put one where direct substitution works, and you end up doing all this work, maybe even get the wrong answer, and it's only because you didn't try direct substitution. So look for that in your quiz. That's a hit for you. That's a hit. Did anyone write that down? Hopefully one person wrote it down.
Look for direct.
I said try direct substitution. Even if it looks like something you got to factor, what if I did x is 1 to 1? Put a 1 in there and a 1 in there, it doesn't equal 0 over 0, you get an answer very simple. Right? Alright, now, how many of you remember how to factor the sum of cubes? T cubed plus 8. You remember that? One person? Two people? It's not very popular, okay? But let me tell you this. What is popular is what I just told you over here. That if I plugged in a negative 2 and both became 0, then I already got one of our factors. You see that? Okay, so the rule here though is if you're trying to get x to the third plus 8, that's the sum of cubes, then it's going to be t plus 2, t squared minus, and then you multiply these together, 2t, and then you have 2 squared is 4. This is the factored form of this sum of cubes. And you might be thinking, Mr. O, how else can we get that? Because I don't feel like memorizing that again. I know you already did memorize it at one point. But use your synthetic division then. If negative 2 came out to be 0, do like this: negative 2. Write out your coefficients. 1t to the third, 0t squared, 0t, positive 8, and then do your synthetic division. This is a blast from the past. 1 comes down, multiply by negative 2, we get negative 2. Add them together, negative 2. Multiply, we get 4. Add them together, 4. Multiply, we get negative 8. 0. And 0. So what's our remaining factor? It'd be t minus 2t plus 4. That's exactly what we get here. Okay? So if you'd rather use synthetic division and not memorize this, but just know this factor based on the fact that I plugged in a negative 2 and equals 0, then we could use synthetic division with negative 2, and we can get our other factor here, t squared, minus 2t plus 4. Okay, so either know what if you're asking me, some people were surprised, they said, what about the quadratic formula? Think that'll be on a test? And I said, yeah, why not? And then this one, this here, you say, are you really going to make us memorize the sum of cubes? Yeah. Because you don't need to memorize it if you want to just use synthetic division. This is what Ms. Holtman always says, and I agree. Minimize what you memorize. You don't want to just spend the whole year memorizing stuff. You want to understand the basics, the background of it. Okay. Next, on the bottom, I get t plus 2. And then this is where the magic happens. Boom, boom. Now if I plug in negative 2, we're not gonna have to worry about this factor anymore. So we can use the direct substitution. By the way, I should have put the limit notation here. Limit as t goes to negative 2. Okay, down here we could say we plug in negative 2 squared minus 2 times negative 2 plus 4 over 1. Right? There's nothing left down here. It's just over 1. So this equals 4 plus 4 plus 4. So the answer to that limit is 12.
How did we know that we had to expand the t as in t squared minus 2t plus 4?
How do we know we had to factor it?
Yeah, well, how do we get it to be that?
You had to. How do we get this, or how do we know to do this?
How do we get that?
Well, I gave you two options. You could either know how to factor the sum of two cubes. There's a sum of two cubes and a difference of two cubes, which you knew from algebra 2 and pre-calc. Or the other option is you know that one of the factors is going to be t plus 2, based on the fact that plugging in a negative 2 got me 0. And then you can use synthetic division based on that to get the other one.
Wait, so can you use synthetic division for both sum and difference of t cubes?
Yeah, absolutely. Question?
Yeah, is this as x approaches negative 2 from both directions?
Both.
Okay. And would it be any different if it's approaching?
One side limit would be the same.